action. The other thing I'm doing is I'm recording the actual lecture as a little video presentation. I can't make that available yet, unfortunately. But hopefully by this fall, they're going to have a server where we can make these lectures available also. So this is more experimenting for me than anything else as far as the mic goes and stuff like that. But we'll see how it goes. All right, so the indefinite integral. What is this all about? It's about what we call the antiderivative, which means going backwards. Okay? So this symbol here is called the integral. The integral of, and whatever's in here, this is the function. That's the function there. And then this right here is read, you see it says dx, right? The way you read it is with respect to x. So I'm going to read this to you. When I see that problem, how do I even read it? This says, take the integral of 2x minus 3x squared with respect to x. Okay, now that's a lot of jargon. But what does it mean we're doing? What it means is we're finding an antiderivative, okay? It means find a function. So I'll say this. Find a function which I'm going to call capital F of x, such that, by the way, what does this mean? That means derivative with respect to x. The derivative with respect to x of f of x. Okay, what's the other way of writing that, by the way? You can write, yeah, if it's a function y, you can write dy dx. So I could have written df dx. There's another way of writing derivative. I did it up here on the board, right? You could write f prime of x, okay? But what this integral problem is asking us to do is to find a function capital F of x such that f prime of x is the stuff inside. 2x minus 3x squared. Get that? You have to come up with a function so that if I take the derivative, this is what I get. All right? I'm going to turn you loose on it for a minute, but I'm going to give you one hint. If you just worry about it one term at a time, it's easier. Okay? So my question is, what would the function be such that this happens? Could that be what it is? Well, I don't know. How do I check? How do you check the answer to one of these integral problems, integration problems? Well, you have to do your applied calc 1. You have to take the derivative. So let me try it. If I think this is the answer, then I would do f prime of x is 2x minus 3x squared. What's the derivative of the number 4?
0.
It's 0. So plus 0. Which, of course, is that. So some of you guys put this, and you're right. This is an antiderivative. Right? And this is also an antiderivative. Because the derivative of a constant is 0. And that might be confusing for people that don't remember this. How do you explain to someone that the derivative of a constant is 0? What's that? You just say that it's 0. Well, let me ask this. What does derivative mean? We went over that at the beginning of class. What does it really mean about the function? It's the slope of what? Of a tangent line. And like take this example right here. If I were to graph the function y equals 4 on the coordinate plane, what does it look like? Well, all lines are straight. But yeah, what does it look like? a horizontal line, right? So we go wham. I do that all the time too. So let's see. It's there. And now if I say take a tangent line to that curve, to that line, well, a tangent line is going to be the same line, right? And what's the slope of any tangent line there? So that's why 0 is the derivative of a constant. That's a nice way of understanding it. So somebody gave me this once. What do we think? Is that okay? Why not? Right? Here's a function. And if you take the derivative of that function, don't you get what's in the parentheses? Yeah. And so to avoid that confusion, some of you have learned, we do x squared minus x cubed. And then what we write is we write for an indefinite integral, we write plus c plus a constant, where that constant could be any number you want. Okay. And so there's the answer. That's the answer we should have. And by the way, I never understood the point of this, putting the plus c. It's like, no kidding. I used to lose points on my exams for not putting the plus c. You'll probably put the plus c. We want to try and find the antiderivative. Something that if I took the derivative, it would give me the square root of x to the 5th. So this says the integral. So, first thing I would do on this is I would rewrite the problem. How many of you did that? What'd you write it as? So integral of x to the 5/2 power dx. That make sense to people? And then people do this different ways, but I'm going to start off here by telling you how I think about it. When I'm doing an integral, if I can write it as a polynomial or as basically an x with some power up there, that makes it easy. Now all I have to do is I say, well, I know the answer is going to be x to what power? 7/2 power, right? I know that that's what I'm going to need because I know my rule about derivatives. When I take a derivative, bing, I bring this out front, and then bing, I subtract 1, and there's my x to the 5/2. You guys with me on that? Of course, this is not the total answer yet. If I thought that was the answer and I took the derivative of this, I would get 7/2 x to the 5/2. But I don't have that 7/2 there. See that? So what do I put out front to compensate for that? If I put 2/7 out front, so that 2/7 is already out front, what's going to happen when I bring down the 7/2? It all cancels out. Do you guys see how that works? So the antiderivative of x to the 5/2, or another way to say it, the integral of x to the 5/2 dx equals 2/7 x to the 7/2 plus what? Plus c. Nick? Okay, I added 1. All I did was I said, well, I'm going to do 5/2 plus 1. But how do you do that? You have to write 1 as a fraction. How would you write? Sure, so I'm going to write it as 5/2 plus 2/2, and that's how I get the 7/2. So the reason we add 1 is because when we take the derivative, what are we going to do? We're going to subtract 1. Does that make sense? Good. What about this one? First of all, how do I even read that? It says the integral of 1 plus 3t, and then what? I guess times t squared, because that's what it means when things are next to each other, right? And then how do I read this? With respect to t. Okay? The integral of 1 plus 3t times t squared with respect to t. Okay? Well, let's start out by rewriting it. We're going to rewrite it as a polynomial. And then it's going to look easier. So we're going to write integral of, and the thing I want in here, I'll keep the dt, but what I really want is I want a polynomial. So you know what I end up doing? Distribute. Yeah, I'm going to take this t squared, which is multiplied by the stuff here in parentheses, and I'm going to distribute it. Okay? So when I distribute it, I guess I get, let's see, t squared plus 3t cubed. Okay? Is that right, Station? Okay. So now I want to try and take the antiderivative of that. Why don't you guys give that a shot? So let's see. Integrate t squared, and I get, well, I know it has to be t cubed, but what do I want to put out front? 1/3. Because then, see, remember, anytime you take an integral, an antiderivative, you can always check your answer, right? So that you take the derivative and see if you get back what you started with. Plus. Now again, I'm going to deal with the power first. It's going to be t to what power? And then I ask myself, well, what should be out front so that if I took the derivative, I would get 3t cubed? And it turns out if you put a 3/4 here, and now 4 times 3/4 would give you the 3. Plus c. So there we are, antiderivative. Now sometimes you can actually figure out what c is in a certain problem. I want to bring that up because we're going to use that in the upcoming applications. So suppose I tell you something about the derivative. I tell you f prime of x is 2x. And then I give you this other little fact, f of 0 is -4. My question is, can you tell me what f of x is? That's the problem here. Find f of x. Find the function if I know what the derivative is and I know a point. How'd you get that?
Took the antiderivative of 2x squared.
So you said I'm going to take the antiderivative of 2x dx, right? The integral of 2x with respect to x. And you said that's x squared.
Right. So if you put 0 into that, you get 0. So -4. That makes sense.
Yeah, but I want to make sure that we're all there. Okay, so first of all, everyone's with me on this? Is that okay? Now, what is that? In other words, well, actually, I didn't write something. What did I forget to write? I didn't write f of x, but I also didn't write. So f of x is going to equal this antiderivative, which is, plus c. See, the whole point here is that sometimes you can figure out what the c is if I give you an extra fact. This piece of information is going to tell me what c is. And so here's what Alex said. He said, well, look, we know that f of 0 is -4, right? So I'm thinking what you did is you put the 0 in for the x. And then this is f of 0 then, right? So -4 is c. And so his final answer then is f of x is x squared, and then what will we write? -4. That's a bit fast, so I want to do one more thing with this. I want to graph it. So what did I tell you? I told you that the function, well, I told you the derivative of the function. That's one thing I told you. And the other thing I told you is that f of 0 is -4. So we could plot a point, right? Well, let's plot that point. So x is 0, and y is -4, so I'll go down 4. right there, I know that the function goes through that point. You guys with me? Okay. Now I'm going to graph a few other functions on there. So let me graph y equals x squared. What does this look like again? That's a parabola. Goes right through 0, 0. Right? And now I'm going to graph another function. I'm going to graph y equals x squared minus 2. Okay. What's that look like? It's a parabola moved down 2. That's right. So it will look very much like this, but it's moved down 2. Okay? So now if I say, what's the function f of x we wanted? Well, they're all parabolas. All the antiderivatives are parabolas, right? But we want the one that goes through this point. And so basically, the f of x that I want is, in fact, this parabola. Okay? And we're going to come back to this picture. This is when I said we're going to study some differential equations. If this is a differential equation, which it just about is, then this is what you'd call an initial condition. Bless you. All right, so that's the initial condition tells you which of these many, many curves we're talking about. We're talking about the red one. And by the way, when you write plus c, the c could be anything you want, right? It could be the green one, the black one, the red one. It could be anything. If you graphed all of them, that would cover the entire plane. And I don't know if you could see that or not, but it'd be a whole bunch of parabolas. Just you move them up or down, you can hit any point on the plane you want. And that means if I tell you one point, I can tell you which parabola I'm talking about. I can tell you what c is. Okay. In our book, when our book writes MR of x, do you guys know what that stands for? This is going to be marginal. When they put an m in front of a variable, it means marginal. Marginal revenue function. And depending on the number of business courses you've taken, you may have dealt a lot with these already. I don't know. Or maybe not. This may be your first encounter with them. But for us, maybe the first thing to know is that marginal revenue is the derivative of the revenue function. So if they tell you marginal revenue, you know you're talking about a derivative. R prime of x. Oh, and one thing I like to do when I do problems like this is I always want to write down what do my variables represent here. So like x, what does x represent? Well, we have to read it. Okay. X is number of sunglasses produced. Number of sunglasses produced. Well, this is a daily marginal revenue function. So that means per day. So they could make none, or they could make, if they're off that day, or they can make up to 540 in a day. And then the units here, MRX, those are dollars, right? Those are dollars. Okay, so here's problem A. Knowing that so it says R of x equals 1487.5 when x is 50. A short way of writing that is this. R of 50 equals 1487.5. I guess my first question is, what does that mean? Yeah. They produce 50 sunglasses at their factory, they're going to get $1,400 in revenue. $14.87 and 50 cents. What do they charge? I wouldn't get that, I guess. But that would be the revenue that they'd make for 50 sunglasses, right? So if we know that, it says, find the revenue function, which I'm going to call R of x. All right, so I'll do that. So how do I do that? Well, this is R prime, right? So what I want to do, R of x is going to be the antiderivative of mR of x dx. Is that okay? So I need to take the integral of 30 minus 0.0003 x squared dx. Okay? Equals so what do I have here? Well, when I take the integral of 30, the antiderivative of 30, what would that be? We haven't done that one yet. Right. Because what happens if you take the derivative of 30x? What do you get? You get 30, right? So again, if you can take derivatives, you ought to be able to do this. It's just going backwards. Takes a little thought, though. Okay, minus. Now here's how I do this again. I say, well, I know it's going to be x cubed, right? So then what number do I put out front? There it is. 0.0001. Because if I took the derivative, right, I would be multiplying by 3. So in a sense, what I had to do was divide by 3 in order to get that. Is that okay? And then I'm going to put plus c. Don't forget that. So this is R of x initially. Now we want to figure out what the constant is. Okay? So now, what I do next is I use this information down here in this step. And so what I do is I say, well, I'm going to plug in a 50 for x. So I get 30 times 50 minus 0.0001 times 50 cubed plus c. What's that all supposed to equal? 1487.5. Right? And this is just an algebra equation with one unknown, the c. So you ought to be able to solve it for c. All right? I guess I could do a little algebra with you. So times 125,000. Okay. So let's see. 1,500 minus 1487.5 would be 12.5, huh? So I get 12.5 plus c equals 12.5? Wow. So what's c equal? So after all that, c equals 0. Okay. So what's my final answer? My revenue function R of x equals, well, just this piece, 30x minus 0.0001x cubed. So how much are they charging per sunglass? Per pair? Looks like they're charging about $30, right? And then they subtract a very small amount. Although that amount gets more and more significant if X gets bigger and bigger. So for some reason, your revenue goes down when you start talking large numbers of sunglasses. And I'm not sure why. The business, what's behind that model there, but that's the idea. Now, we did not do part B of this problem. I don't plan on it, but I do want you to look at it to see if it looks familiar at all. How many have seen before a price-demand function? Some of you, okay? It's just the idea that revenue, notice it says, is quantity produced, which we're calling X, times the price of each unit, P of X. I don't want to do that now. I just want to see if you've seen that before. We'll deal with that later. So any questions on this part, though, part A? In this problem, the first thing I want to point out is that R here does not mean revenue. I told you guys, always figure out what the variables mean. In most cases in this book, capital R is a revenue function, but not here. So what do we have? Well, we have X, first of all, is the number of years since, what does it say? 79? Okay. So what years are we talking here? Between 1 and 20, it says. Up to 1999. Yeah, 1980 to 1999. Okay. And what's this a model of? Is it? Rate of sales of lotto tickets, right? So, yeah, R here is a rate of sales. And like Ange said, it's millions of dollars per year. Okay? Millions of dollars per year. And the units are essential to understanding what's really going on here. See, when you see that it says you have a rate of sales, okay? Well, you're saying rate of change, right? Rate of change, that's what you guys told me is what? The derivative. This function R is a derivative of something. How do I know that? I know it from the units. See, that's a rate. Millions of dollars per year. By the way, the denominator, what are the units of the denominator? Years, right? So another way to write this is you can write it as a derivative. If I write dx, does that make sense to you guys? Because x is a number of years, and the units here are per year. You guys follow that? It might make sense more when I go about what the numerator is. Rate of sales, millions of dollars per year. So in other words, R here is another way of saying ds dx, where s, what's s? Now why did I pick s? Well, because I looked at the problem. Doesn't it say find s in part A or something like that? Where's it at? In part B and part C, yeah. Knowing that there's a certain number of lotto tickets, recover S, the ticket sales function. Evaluate S of 17 and interpret. See that? Okay. So let me go ahead and just walk through the exercise with you, and then we'll take our break. You're going to need a calculator for this kind of stuff. I mean, at this point, let me take one out. So let's see. I have one somewhere. There we go. Okay, I have a TI-83 Plus here. So let's see, what am I going to do? I like to use it this way. I like to put my function in the y equals screen so I can see a graph of it. That helps me. So I'm going to write y equals. Make sure that plot's not highlighted. And I'm going to go ahead and type in the function. So what do we have? Negative 8.67 x squared plus 113.98x plus 516.58. Is this okay so far? Felix, you all right? Okay. So now I have it in the calculator, and then what I'm going to want to do is I'm going to press graph. But if I press graph, actually I probably won't see anything. Because when you press graph, it just shows you some screen. The thing you need to press is window. You need to change the window so you'll be able to see it. And that is probably the hardest part of graphing with these calculators. Now luckily, they told me something. They say, well, the model, it goes, see if I look at the problem again, from 1 to 20, right? So let me get that calculator back up here. And where it says x min, I'm going to put 0. And where it says x max, I'm going to put 20. So that those are the years that I'm graphing, from 0 to 20. So basically from 1980 to 1999. And then here, x scale, you can put a mark every so often. I'll put a mark every 5 to help me look at it. Okay, y min and y max, here you're more like, well, good luck. Okay. If you look at the function, it might help you. See, like if I put in a 0 for x, I know we're not starting at 0, but on the calculator I will. What's the sales rate going to be when I put in a 0? 516.58, right? When I put in a 20, I don't know what's going to happen. I do know this. What shape is this curve going to be when I graph it? It's going to be a parabola, opening up or down. How do I know it's opening down? You have a negative sign there, right? So it's a parabola opening down. So it may go up for a little while, but then it's going to start going down. And I'm guessing when I see a number like 516, let's say I go from, yeah, up to 1,000 maybe. So, okay, I'll go from negative 1,000 to positive 1,000. And really, this is a guessing game. It may not work. And I'll put, every 500, I'll put a little mark. Okay? And if it doesn't work, then I'll try again if I need to. But I'm going to press graph. That's not bad. That's not bad. At least I could see it. Okay? So, got that? Okay. So now what I do is I want to go ahead and answer part A. It says evaluate R of 17 and interpret. The fast way to do this, you guys all know this tool? If I hit the second key, and there's that button trace, above it in yellow is written calculate. And here's a value. So if I calculate x equals 17, what it does is it just shows me right away what would happen if I plugged in a 17 for those x's. That's kind of nice. So we get R of 17 equals, what was it? Negative 51.39. Okay. So how do I interpret? That's the big key for this class. Yeah, we can do that. We can plug it into a machine. Anybody can do that. What does it mean? Okay, so first thing is what year? Yeah, in 1996. There you go. Sales decreased, or sales, how about this? Were decreasing at a rate of $51.39 million per year. Wow. Company's going under. That's what I think. Yeah, stock market's crashing there, huh? They said the 90s were good, but not for sunglasses, apparently. Or for lotto tickets. Not for lotto tickets. Okay, part B. Knowing that there were 8,563 million in lotto tickets sold in 1990. So this is part A. Part B. What's the given info? Well, it says something about 1990. So what is it? What x should I use there? 11. So R of 11 is 8563. 8563, right? And then what we want to do is we want to find S. The ticket sales function. This will be S of x. Okay. So here's what I do. I'm going to say that S of x is the integral of R of x dx. So that's the integral, well, of this big mess. Now what I usually do is I put parentheses around this thing and then put the dx here. Some books don't put the parentheses. I don't know if our book always will or not, but this is what I usually do. So that's the thing we're trying to integrate, the thing in parentheses. All right, so let's see if we can do it. So how do I integrate this? Well, it's going to be x to the third power, right? And then I have to say, well, what constant do I want out front? Well, rather than work it all out, I'm just going to say that it's going to be negative 8.67 divided by 3, right? Because when I take the derivative, the 3's are going to cancel, and I'll be left with that. Is that okay? Plus, what's next? Yep, it's going to be x squared. 113.98, and then I'm going to have to divide by 2. And then I'm going to have 516.58 x, and then I'm going to have plus c. Okay? So this is S of x. Oh, time out 1 second. I made an error. Do you see it? The given info I wrote here is not right. Can you figure out what I did wrong? It's not a rate in that year that they gave you. They told you what? The sales. So really they told me that S of 11 is 8563. And that makes a difference. Because now what you can do is you could plug an 11 everywhere for the x. So if I do that, it's going to look like this, right? S of 11. That's going to be 8563. Okay, that's going to equal negative 8.67 divided by 3 times 11 cubed plus 113.98 divided by 2 times 11 squared plus 516.58 times 11 plus c. You would now be able to solve that and figure out what c is. I'm not sure I want to, but I will. So let's see. Need a blank sheet. I'll do it on the board. We'll just stop it here and